and programs design. And so we are privileged to have him presenting some of the concepts and basic understanding of GIS to us today. David Ramdeen, please, you have the floor. Thank you.
Thank you, Afia, and thank you, everybody, and welcome. As you see here, there are just some guidance here with respect to your microphones. So just please keep your microphones muted during the presentation, and I'll begin. Okay. Afia, I'm seeing you on the screen. I don't see my notes. I don't see my presentation. Is everybody seeing the presentation? Or are you seeing Afia?
No,
No, you're not sharing.
No, I don't see
you
the
guys.
presentation.
Okay. All right. So let me go ahead and reshare again and see if that. Okay. How about now?
We do see.
There you go. Welcome
All right.
page.
Wonderful. Wonderful. All right. So let's begin. All right. So I want to start this this presentation, or if you will, a conversation, with a quote by Edward Wilson, who is an American biologist, naturalist, ecologist, and entomologist. And he says, "We are drowning in information while starving for wisdom. The world henceforth will be run by synthesizers, people able to put together the right information at the right time, think critically about it, and make important choices wisely." That is one of the things that we're seeking to do with GIS, to glean the information that we can actually glean from taking geographic considerations in geographic factors into consideration to actually make good decisions, wise decisions for ourselves as an organization. As Afia stated, my name is David Ramdeen, and you've joined the Technical Learning Lab webinar, Simplifying Geospatial Concepts and Utility for ADRA's Work. And as she mentioned before, this is the first of a two-part series. The first being, second being presented tomorrow by my esteemed colleague, Joseph Dindiak, who's also on the call. And he's joining from ADRA Ghana. So again, thank you everyone, and welcome. So there is untapped knowledge in geospatial science. In terms of purpose, geographic information science is about unlocking and unleashing the wisdom that can be synthesized from various kinds of data in terms of their geospatial characteristics. Wikipedia defines geographic information science as the basic research field, that seeks to define geographic concepts and their use in the context of geographic information systems. It also examines the impact of GIS on individuals and society, and the influences of society on GIS, which indicates that there's a reciprocal relationship between the science and people. More to the point, GIS is relevant for the work that we do as a global humanitarian and development agency. The importance of geographic information for the work that we do in so many different contexts, geospatial aspects especially, is that geospatial aspects are important considerations in every human context, including the ones that are listed on the slide. So it's important for how we consider conflict, vulnerability to natural hazards, local capacity, the viability of development options or approaches that we might be considering, how the population is distributed, who and how people access infrastructure and natural resources, housing and settlement viability, resilience, sustainability, and people's general adaptability to climate effects. So there's a whole range of activities that we do and that we and areas in which we implement, for which geoscience is relevant, and that's one of the things that I want us to consider today, as we go through some of these different concepts and we learn a little bit more about GIS. So it's also important to know that institutional donors like USAID, for example, they're driving their partners to adopt geospatial language and tools, and being on the sort of on the leading edge of this change comes with certain comparative advantages as we compete with other organizations for what is essentially a decreasing set of funding opportunities. So the use of geospatial language and requirements is expected to increase in the information that's released by donors. USAID especially have indicated their intention to do so. And in fact, in 2022, October 2022, if I remember correctly, USAID released a draft geospatial strategy for comment. I provided comments on behalf of ADRA, but the document is currently under agency review and is expected to be released sometime soon. So essentially, GIS makes us more competitive in terms of the lines of business that we wouldn't otherwise consider, because there are so many geospatial aspects associated with those lines of business or sectors, if you will. And a good example of that is Feed the Future, which is, I would say, one of the larger, it's the area of USAID where there's a larger amount of funding directed. So that and in areas that ADRA actually does good work. So that's something that we need to consider as we go forward. So just to get us on a good footing with geospatial thinking and its utilization for developing and improving programs, we're going to go over some basic GIS vocabulary and concepts, and we're going to talk about how to incorporate geospatial thinking in program design and business development, and we're going to get acquainted with some free sources of geospatial information that will sort of help you on your journey to become more conversant with the science and with the technology. Because in fact, being capable of creating and sourcing geospatial data and being able to access GIS technology and to conduct basic visual analysis is going to actually, just that alone is going to get you a long way in terms of your relationship with GIS. So there are some very basic facts that you should bear in mind as you approach the subject matter. And we have just a few here, and there are some that you'll actually figure out on your own. There's a lot of misinformation out there about what geospatial science and GIS is. And the result of this misinformation is that people tend to think of GIS as something that is high science. And in actuality, it is something that is accessible to all of us. And it's a science that we can actually incorporate into most of the work that we do. So the first is that GIS technology was created to power the science, but in actuality, they are separate things. So just on that point, we tend to think of GIS as just something that you do on a computer, that you need to be somewhat that you need to be very, very conversant with computer science. But the fact is that the science is something that can be understood separate from your time in front of the keyboard. And once you actually understand how the science works and how the data that drives the whole GIS technology, how that actually works, it becomes a little bit easier for you to actually approach the technology aspect of it. The other part is that most of us routinely use and generate geospatial data without even knowing that we do. If you have a smartphone, for instance, and you use let's say Google Maps to get directions or any such application, the fact of the matter is we are actually generating data geospatial data that these major tech corporations are actually using to that are a part of their business model. And the fact of the matter is that we, being generators of so much geospatial data, we get the least use out of this data that we generate. And I think it's for us as an as an organization, as an industry, we need to reverse that paradigm. There are plenty of opportunities for us to do good work or to improve what we do with all the insights that are possible by applying geospatial science and technology. And I think once we become more conversant at doing that, the work that we do will be immensely, immensely improved. So more to that point, here it says you're ahead if you understand the concepts of latitudinal and longitudinal lines. And that's another important point. Most of us in high school, we learned about lines of latitude and lines of longitude, and we learned how to read a map. We learned how to actually find things on a map and how to plot things on a map. And in essence, that is what the entire science is based on. And it's important to bear that in mind. I mean, if you consider that much of what you will need for your experience with GIS is something you learned, years ago. I'm sort of making the assumption that there's nobody in high school on this call. But it actually makes the science a lot less intimidating and more approachable and useful for you. And in fact, the hardest part is figuring out what data sets are relevant for you to consider when you're getting involved with GIS. How do I start? What do I need to know? What specific data points do I need to sort of take into consideration as I decide, you know, how to go about my GIS analysis? What parts of the technology will I need to incorporate when all is said and done? So what we're going to talk about today is going to help you, is going to help to move you along a little bit in that direction, give you a little bit more information and make that question a little bit easier for you. And just to, so this presentation is going to go for, possibly about 30 minutes. And then there's going to be a question and answer session that will allow you to ask all the questions that you need to ask. All right, but there's more information here in terms of basic things you need to know about GIS. And it's that even a basic visual analysis of geographic features can give you a high level of insight. I mean, if you're looking at a map, for instance, with that sort of plots out the infrastructure for a health system, where all the hospitals are. And for instance, you also have plotted out, from a different data set, you can see basically where all the where ADRA offices are located within that particular space. You can see where all the government offices are located. You can see where all the schools are located, where all the the water facilities are located. There is a lot that you can actually sort of decipher just by looking at that. You can see exactly where there's a clustering of these different parts of infrastructure. You can see where there are perhaps gaps. You can see where there might be issues accessing certain points, certain infrastructure elements by certain set of population, that by certain part of the population that's located in a specific area. So, there's a lot that you can get by just looking at all this information on a map. I mentioned before that most of us with smartphones, that we actually generate a lot of GIS data. But the fact of the matter is, for most of us who are out in the field and we are meeting people, we're actually seeing the infrastructure and meeting these people, and we're face to face with the conditions, with the human conditions that people live with in these different contexts. Just that smartphone that we have in our hands allows us to mark things. I'm sure most of us have the experience of creating a waypoint on a map, marking a specific location. And in fact, if we get in the habit of actually doing that for if we think about doing that every time we go out in the field, and creating geographic markings for, that are significant for the work that we do, at the end of the day, or rather I should say, within a certain period of time, we will actually end up with a fair amount of geospatial data that we can actually go back and examine. We can plot it out on a map and examine this data and gain some insights from that. And in terms of how we actually organize this data, and this is a key point that's very, very important for everything else that you learn today. It's basically how GIS data is structured. It's actually very simple, because all the information and features that you see displayed on digital maps or they're stored in a table format. And in fact, the computer analyzes and utilizes this data to answer the spatial questions and solve the spatial problems that you present to it to calculate. So just bear in mind that whole notion of a table sort of being the very basis of geospatial data, because we're going to expand on that in the following slides. Okay, so building on that, the objects that power geospatial science are these formatted structures called attribute tables. No, this slide was prepared partly in jest. No, it's not that kind of table. It's actually the kind of table that you see here depicted on the right side of your screen. Here, I did a very basic example of what an attribute table might look like. There's a column for X coordinates and for Y coordinates. Just think in terms of axes there. The name of the country, the name of a province, and a district. That information, let's say that table were fully populated, that could be imported into, let's say it's in a CSV format. That table could be imported into several GIS applications and actually displayed on a map just based on this table. So this table is, this idea of an attribute table, and I'll explain exactly what the attribute applies to in a moment. But this here is the basis of, of the technology and the science as we know it. So as I indicated before, the attribute tables are what power the science, and GIS applications work by analyzing and visualizing the relevant data points in that table, or the attributes, that correspond to specific geospatial features, lines, points, and polygons. For most of us who are getting started, those are going to be the primary elements or feature classes, which we'll touch on in a moment, that you work with. And the technology helps to visualize the location data and to analyze the attributes in reference to the location data within that table. And like I said, it's structured in a table format, and you can think in terms of Excel or Word tables. So to the right of the to the right of the screen, you'll see what appears to be a bunch of waypoints. That's an excerpt from a map I created while working with the District Department of Transportation in DC. Locating all the commercial loading spaces within the district. My job at the time was to help the agency to develop essentially an efficient allocation of loading zone space. Before I joined, there were so many loading spaces within the district, and there was not an inventory of any of it. I mean, there was not a list of where these loading zones were located. So we had to sort of essentially inventory all of these loading spaces and make some decisions as to whether or not these were located in areas where they were needed, and whether that space would be better allocated to some other aspect. So that's just an example of how GIS can actually help to make decisions within an organization. And here is an example of an attribute table. This is from Ecuador, and the table you see here is actually an attribute table that I sort of did a screenshot from in QGIS. And to the right is a map projection of that data. So the table on the left and the visual representation of that data on the right. So that speaks to what I mentioned between the relationship between these attribute tables and the actual mapping that you see when you look, for example, on QGIS, or even when you see things displayed in Google Earth. You see these different waypoints and markings. Those are all projections of an attribute table. So just to go over a couple more things about attribute tables, as I mentioned, they basically contain the characteristics relevant for analysis and visualization. And the three types of data that they contain are geospatial data, that is location, shape, area, etc. Metadata, which basically is kind of the data that the computer uses basically to do its work. The format, the date, the file, the attribute table was created, who created it, the date that it was modified, and things like that. We tend not to be we tend not to enter when we collect geospatial data or any kind of data. It's just data that the computer assigns to the attribute table. And of course, there's attribute data, which is columns of data added for analysis, measurement, and visualization. So we essentially are the ones responsible for creating the columns to enter the data that we need. Okay. All right. So one moment here. So each row in the attribute table corresponds to a geospatial feature, a line, a point, or a polygon. And each column represents a data point that corresponds to the geospatial feature. And GIS technology helps to visualize the attributes and analyze them in terms of the location data. Okay, so that brings us to feature classes. And again, sort of a comical depiction of feature classes here. But the name doesn't really say, it really doesn't give away what it is. The name feature class is an important part of your basic GIS vocabulary that you'll need to remember, and I'll get into that in just a moment. So just to synthesize the terms we discussed so far, just to sort of bring it together, the attribute table is the way that geospatial data is formatted for interpretation and visualization by GIS applications. Each attribute table is of a particular feature class. So it may be lines, points, polygons, or any of the other feature classes listed in the small text box on the slide, but it's one of each. You won't find an attribute table with multiple feature classes. So if it's an attribute table of lines, it's all lines. If it's points, it will all be points. If it's polygons or shapes, it will be all of that. It will be only that. And when doing a geospatial analysis, two or more of these attribute tables, whether they are of the same or different feature class, can be imported and layered within the same conceptual geographic space. And the spatial relationships between their different attributes can be calculated for factors such as density, average distance apart or clustering, overlap, coverage, and several other metrics. For instance, it might be interesting for us as an organization to know that there is a 30% geographic overlap between 3 different projects that we're working on for 3 different donors. It might also raise questions about the location of your project offices and whether you have the most efficient use of your leasing budget. So this is just one example of how geospatial analysis can actually help you make some smart decisions. Um, and this would require a very basic function, a very basic operation within a GIS application like QGIS. So, there is a lot that you can do. Once you understand how the technology works and you're able to do a little bit within these applications. But essentially, just to define feature classes again, feature classes are homogeneous, and that is important to recall. So they're homogeneous collections of common features, each having the same spatial representation, such as points, lines, or polygons, and they have a common set of attribute columns. So as I mentioned before, lines, points, and polygons are the most essential ones for GIS beginners, especially for map creation and visual analysis, but there are several others as noted here in that small box to the bottom right of your screen. So conceptually, a layer is the visual representation of geographic data sets, of a geographic data set. So for someone starting out in GIS, you'll be working almost exclusively with what's known as vector data, which allows you to make changes. The other kind of data that you'll be working with is raster data, which is a graphic pixel type data in terms of its composition, but can't easily be manipulated. So you won't be working a lot with raster data, but you'll be working almost exclusively with the kind of data known as vector data. So to define a layer is the visual representation of a geographic data set in any digital map environment. And layers of data can be superimposed in a GIS project to analyze spatial relationships across feature classes. And here I'm encouraging you to think in terms of multiple attribute tables in a single GIS project. And as I mentioned before, there's one feature class per layer. It's also important to bear in mind that GIS analysis can be simple or it can be complex. I would encourage you, once you're getting into the science and into the technology of GIS, to start off simple, okay? But whether or not your analysis is simple or complex depends on what you want to know. Where there are a few layers and a few rows in each attribute table, and the question you're trying to answer is simple, usually a simple visual analysis should be enough. And analysis with multiple layers, with multiple attributes, and lots of rows in the attribute table would naturally require more sophisticated technology. And that is where some of the more sophisticated GIS applications like ArcGIS and QGIS come in. One more thing to remember is that layers, or if you want to just say attribute tables, they come in several digital file formats. Okay, it's important for you to sort of become conversant with the different file formats, so that you'll be able to recognize, geospatial data when you come across it. Excuse me. So one of the really cool things about these layers is that they can be converted to different formats and shared between numerous GIS technology platforms in various file formats. And even a GIS file in a CSV format can be imported and exported from GIS programs and converted to another file format for utilization. That's something that you'll have fun doing while you as you get to more familiar with the technology. You'll figure out how to export, how to plot something out in Google Earth, for instance, export it as a KML or KMZ file, and then upload it into QGIS or ArcGIS or some other application that recognizes the KML file format or the file type. So the KML and KMZ formats can be uploaded to Google Maps and Google Earth to share layers online, and that's a really cool feature, because sometimes it's easier in terms of actually sharing geospatial information. It's easier to just plot it out on Google Maps and send a link to someone instead of just sending a file by email. It gives you the KML and KMZ formats are Google friendly. As a matter of fact, I think Google invented that file format, and it makes it very easy to actually share GIS data. And it's important to remember, if you've ever used QGIS, which I mentioned is one of the more sophisticated GIS applications, it can even read a zip file. Okay, so it just makes the technology just sort of makes things easy for you. So all these rumors or ideas that are out there about GIS being high science, I would beg to defer. It's actually very accessible to someone who's getting started. Okay, so this point is also very key. Fortunately, when you're starting out, there's a lot of free GIS data available for almost every country. And most of the data is generic in nature and contain information about national, regional, and local boundaries, natural features like rivers, vegetation, and ocean, human infrastructure like hospitals, government buildings, railroads, highways, airports, and bus terminals. And some programmatic GIS information is available from institutional sources like the USA Development Data Library. But there's usually a lot more knowledge to be gained from analyzing proprietary data that has already been geocoded, and from geocoding ordinary program data from your own organization for analysis. And what I find is that, and this is something that we at ADRA International, for instance, could be better. We could certainly improve upon. And it is sort of figuring out how to store and how to organize geospatial data and actually make it available for everyone within the organization to conduct their own geospatial analysis. And from my experience in development and relief, I would say, and with GIS, I would say that it would be of tremendous value for us to start thinking in those terms, because the kinds of programming that we do as an organization, as a the kinds of programs that we take on, I would say, is likely to be something that we've already done. And in terms of actually building on the programs that we've already implemented, especially ones that we have done really well to the satisfaction of our donors, it would be great to analyze all of that, all of the data um, gleaned during the monitoring and evaluation process, and take a look at how that is represented in terms of space, because I can almost guarantee that there'd be some insights to be gained from that that will inform the way you go about the follow-on program. And there are also a lot of GIS applications and utilities, many of which are free. So if you're getting started with GIS, you can download, for instance, Google Earth Pro. You can certainly use Google Maps. There's QGIS, which is free, and there is Geoda, which is also free. All of these um, are very powerful GIS tools. Google Maps, for instance, and Google Earth Pro, pardon me, they actually make a lot of these functions, these beginner GIS functions, very, very easy. And they actually once you get started using them, they actually make you quite excited about the possibilities, and will cause you to start thinking about using more powerful tools like QGIS to do some of the analysis that you want to do. And it's important to mention that there are also a lot of YouTube tutorials for QGIS. So if you wanted to start there, you could go to YouTube and just type in as a search term QGIS tutorial, and there would be you'll find that there are several there. I believe there are a lot in the English language, and there are some in other language as well. I seem to recall seeing some in Spanish and French. So that would be a great place to start if you wanted to, if you wanted your introduction to GIS technology to be something a little bit more sophisticated like QGIS. So what do you do when you're ready to get started with GIS within your specific country office? Well, I would say first, you seek the support of your supervisor, right? The person who is responsible for your time and for directing your work needs to understand that this is something that you want to undertake, because it requires some use of your work time to actually learn and to be able to investigate some of, to actually experiment with the technology a little bit and with the science. Also, learn, start small, and then involve others. So get a little bit acquainted with the technology and the science itself yourself, then start doing small projects to enhance your work, and then you can involve others. And individually, that is yourself, incorporate geospatial questions and language into your analysis of existing and prospective programs. That would be your next step. And also identify and rely on your colleagues who are most familiar and conversant with GIS tools and analysis. Now, in this text box on your right-hand side, I want to make the point that GIS data and information is valuable, right? The insights that you learn, that you gain from doing your geospatial analysis, there is value to that. So I would encourage you also, once you've gone through those first steps that I described, to talk to your IT department about how the data should be stored and who should have access to it, because there should be some data protection protocols applied to your GIS data, just like you would with monitoring data and anything else that concerns the population, or that might have some kind of political aspect to it. So that's important. Talk to your IT department about storage and access. And once you've done that, once you've started doing, once you become a little more conversant with the technology and the science, and you feel comfortable talking about its possibilities and its utilization within the organization, then you can widen the conversation. And you can bring your GIS insights to program discussions. I would encourage you, when you talk about GIS to your peers who are not as conversant with the science and technology, to explain the benefits, explain the concepts in ordinary language where possible. so that you can actually gain the support. It's important for them to feel like this is something that they can access and utilize for their own work. And then collectively, you can incorporate geospatial questions and answers in your analysis of donor releases, and hopefully apply that to some of the larger programs you'll undertake. Like, you know, there are, in the case of USAID, they issue what's called a request for information when they're contemplating releasing a solicitation for, applications essentially. And if we're able to apply some kind of geospatial analysis to that request for information and provide USAID or donors generally some insights that they perhaps haven't contemplated before, then that only serves to show our competence in the eyes of the donor. And to the extent that we can actually, present ourselves in that way, it only benefits us in terms of relationship, in terms of confidence on the part of the donor for the work that we do, and our prospects for future funding from that donor. And importantly, you should enjoy every step of the process, right? There's so much information and insight that you can gain from, getting involved with the science and the technology. I myself get pretty excited when I go through, a few data sets and I notice a certain pattern, or I see something that's of significance that I can actually apply or discuss with whomever I'm working with, that will actually have some impact on the work. So sort of approach the whole GIS, approach GIS in general with some joy, and I guarantee you it will enhance the work that you do. And if you do it well, it will actually help create some opportunities for you as well. So just to summarize, don't wait, get started. Geospatial science is accessible to everyone, and it's developing fast in the development and humanitarian space. It's easy to grasp if you understand the basic science and um, how the science actually sort of creates that it's the foundation, and that it's actually powered by the technology. And for GIS to become a meaningful tool in your organization, it needs to be supported by those who allocate your work and your schedule. And lastly, adopt or see the future to organizations that do. But before we end this conversation, I want to highlight this very important point, which is the factor of privacy and data protection. So I just want to highlight here, just to create this awareness for you. In the collection, utilization, display, or other sharing of GIS data, you should be careful to respect the privacy, safety, and dignity of private individuals and vulnerable groups. Be aware that location data can be used by malicious parties to target and victimize persons and groups based on their geography, ethnicity, political affiliation, and other such characteristics. So I thank you for listening and participating. And at this point, I'd like to open it up for any questions you might have.
Thank you so much, David. It's been a very wonderful. We are open to questions. If you have any, you are free to either raise your hand using the icon at the top of your Teams link, and then you can unmute and speak, or you can also post it in the chat, and we will look at it. Davidson, I see your hand is up. Please unmute and speak. Thanks.
Yeah, David, thank you so much for that. We've had many conversations about GIS. I don't really have a question. but I kind of wanted to add to what you had mentioned about available data. And also point out, especially as I know we have at least one meal person on the line, that we have a lot.
Davidson, you are dropping in and out. I don't know if you can adjust your mic a little bit so we can hear you.
Okay, is this a little better?
Yes, this is better. Thanks.
Okay. All right. So yeah, I'll just say, in short, we have a lot of data already that we can use. That is through meal. Now, quite often it needs to be modified in the sense that combining it with other data, like some of the map data that David was talking about. But we actually do have a lot of data that we can. It requires some work to update it, but I would definitely say that that's would be a good place to start instead of well, not instead of, but if you think, oh, we don't have data, we'll have to go around and find data and this kind of thing, not necessarily. We do have a lot of data, so that's just some food for thought. Again, David, thank you very much.
Thank you, Davidson.
Thanks, Davidson. Alejandra, please go ahead. Yes, Alexander, you're muted. Can you unmute?
Yes, are you hearing me now?
Yes, we can hear you now. Thanks.
Yes,
okay.
Thank you.
1 second, please. Yeah, I want to thank David for the presentation. Actually, you know, what this is interesting to me, just last week, I'm calling from ADRA Caribbean Union. Our headquarters are down in Trinidad and Tobago in the Caribbean. Last week I was with a disaster management training team from our Caribbean Disaster Emergency Management Program. And you know, the folks were spinning some of these things, JS, ArcGIS, QGIS, and so on. And I said to myself, wow, I hadn't studied this thing since I was at Loma Linda doing my MPH. So that was a good refresher to me. But this morning, what David has done has opened my eyes more now, so that I can understand from a standpoint of what this thing is all about, and that it is not that sophisticated as the folks make it out to be, you know, as though it is some hidden science and so on. So I want to thank David for that presentation. And you know, I said before, it's a long time ago since, I mean, I left Loma Linda in 2000, a long time, 20 years ago. David, is there a starter book? You said you can go online and get a video, but is there a simple little textbook on the thing, or no, that you can probably use to support what you find online?
That's an excellent question. I'm not aware that there is a book that actually works well for teaching GIS.
Okay.
But I'm sure, you know, there are tutorial books of you know, just about every subject matter. So I'm sure if you were to, for instance, go online and look up, you know, GIS book for beginners, there'd be a few things that pop up. But what I would encourage you to do, to be quite frank, is to just go in. I mean, if you're interested in the technology aspect of things, I mean, I think most of us, you know, we already have, you know, based on this conversation, have a sense of how the technology is actually constructed and how, you know, what actually makes it work.
Yes.
You know, if you have a computer with, you know, some space to download QGIS, to just go ahead and experiment with that. You know, you don't need any kind of formal book. I mean, you're not going to break your computer by experimenting with GIS, right?
No, I agree with you.
And just go on YouTube and look at those starter videos, and you can actually, you know, work alongside them, do the things that they're doing at the same time. that will
Okay.
make it a little bit more interactive. I think it's a lot more fun, to be quite frank. And I think that tends to build a little bit more enthusiasm for, for it as well. When you're actually
Okay.
doing it
I
with
know.
someone who,
Mhm.
is walking you through the process. So that's what I would encourage. But thanks for the question.
Thank you so much. Really appreciate your answer. Thank you so much, David.
My pleasure.
Yes.
Joseph, you're next.
Yes, David, thank you so much for this good presentation. To just to add to what you have said concerning training or learning, basic learning in GIS, let me add that Esri is the developer for ArcGIS, and on their portal, ArcGIS Online, they have a lot of free courses there for beginners. And what it takes is just to create an account and you are good to go. They are self-paced trainings that sometimes even span for weeks. And you are able to schedule your time to be able to participate in some of these things. So just to add to that, thank you.
Thank you. Joseph, if you share the link with us, we can include that when we share the recording to the participants so they are able to access the link and check it out. Thank you.
Yes, let me do that.
All right, thank you. Herbert, please go ahead. You're next.
Hi. Well, first of all, I'd like to say thank you very much for this presentation. And as I was listening to it, I realized, just like David said, that this is something that we have been doing it without knowing the name of it or realizing that we were doing it, but on a very, very basic way in my case. I'm excited about going more into it and maybe getting the link for those courses that Joseph was talking about. So thank you very much for this wonderful presentation. It makes lots of sense.
Thank you, Herbert.
Yes, thank you, Herbert. Any other questions? Does anyone else want to ask a question?
Yes, Joseph. Thank you for good presentations. And actually, I have a few questions related to GIS application. Actually, I received the training 5 years back under this USAID projects, and currently I am using just drafting the location map, location map, and just using for this purpose. But my concern is, can this GIS application contribute to public health research or modeling, research modeling, or analysis of disease pattern, healthcare resource allocations? It can be used in this perspective? Or and another question is, what are the key data sources and data types commonly used in geospatial analysis through GIS? Are you getting my point?
Yes. Thank you for the question. I would say GIS is very relevant in terms of understanding. Well, let me just say the geographic representation of health infrastructure can actually provide a lot of insight relevant to many subsectors of health. For health system strengthening, for example, you could learn a bit about, let's say, for example, you have information, you have a population data set, and you have a data set about the health infrastructure. You could learn a lot about, whether or not the health infrastructure is actually located where you know, to be of use to where the population is actually concentrated. You could see, for instance, whether or not the health facilities that are in specific areas are properly sized or equipped for the kinds of population that they serve, and things like that. You know, incorporating the geospatial aspect of you know of just about anything will provide some kind of insight and help you in terms of your decision making. At a very minimum, it will actually raise some questions, that are worth answering if you're trying to, if you're trying um, to design or to improve a health system so that it's effective and efficient, and that it serves the population in the best way possible. So absolutely, it is relevant for that. And your second question again, I'm sorry, I forgot the second part of your question.
And last question, what are the key data sources and data type commonly used in geospatial analysis through GIS?
Excellent question. And one of the slides actually it actually hit on that, the different file types. So what you'll hear, one of the most common, I guess, types of data that you'll hear people talk about is shape files. But if you actually get a copy of the slides, I've listed several file formats there that you can find in numerous places. So there is the GeoJSON, there is there are shape files, there are LiDAR files, there are KML and KMZ files, which actually work with Google and are sort of they're sort of an interoperable file format that allows you to analyze and manipulate the data in different GIS applications. So there are several out there. But if Afia, I don't know if you're going to be sharing the slides with everyone present, but that information is contained there, and we'll sort of give you some guidance as to the different file types that you'll be able to recognize and
Yes. Thank you for the answering my concerns. And actually, I am working currently in ADRA Nepal as a MNI manager. I look after the research and evaluation related works. So my main concern is how we can utilize this GIS technology to research or modeling of the different kinds of data. So my concern is basically particularly the research and modeling of the data.
Okay. Joseph, I don't know if you want to take that part.
Yes, David. Yes. GIS, for instance, ArcGIS software supports research work, and you are able to generate autocorrelation maps that is able to tell you whether your data is clustered, whether it's dispersed, or is just by chance. In that case, your data is random. So in that case, if you have a data set and you want to proceed to do some sort of analysis, you can run autocorrelation analysis to see, for instance, if the data, there's any even association established. You need to establish an association between various variables. And for instance, if you run that analysis and then there's clustering, it means that there's an association and you can go ahead to do whatever analysis. You could run regression analysis, and even these days you're able to use Python scripting to do a whole lot of statistical analysis. And ArcGIS actually has what is a spatial statistical analysis tool, and you have various statistical indices that can be generated from this. So it supports modeling.
Yes, thank you. Thank you.
All right. Thank you all so much for the contributions, the questions. This has been a very insightful webinar. And I would want to note again that tomorrow we have the second series of this webinar that looks at how GIS has been applied in different sectors in the development and humanitarian field. So I look forward to all of you joining us for another very interesting session. David, thank you so much for your time and for the wonderful presentation. Thank you, Joseph, for all the contributions and support. And thank you to everyone, including our translators, for doing a wonderful job. I look forward to meeting all of us tomorrow, same time, for the second series of the webinar. Take care. Have a lovely rest of your day, morning, afternoon, or evening. Bye, everyone.
Bye, everyone. Thanks for participating.
Bye.
Thank
Thank
you.
you.
Thank
Bye
you.
bye.
Thank you.